Hello everyone. I hope everyone's break was well and you guys are all healthy and keeping up with the work, and I hope that you also consider doing the bonus point for the exam. I've been sending emails about it. So yeah, we are starting the last quarter of the class of the semester. Things are gonna ramp up quickly, but also we are skipping some of the parts, that just so you know. So I would like to briefly review what we talked about before the break, and which are important for the exam later on. So first thing I want to discuss is the energy conservation. And energy conservation, we apply some methodology, right? So first thing is write down the equation. So the equation is kinetic energy change plus potential energy, but this one is gravitational potential energy change, and then elastic potential energy change, and then internal energy in general term, and internal energy due to friction, or you can also call this one thermal energy. I'm just gonna label it as delta IF. And so we split some parts here, and that we said that that's equal to work added or taken away from the system plus heat. Okay, so this is you just write this equation. Second step is simplifying it. So you're going to think about what changes kinetic energy, what changes potential energies, what changes internal energies, and if there are those reasons to change those energies, you're going to keep those terms. Otherwise, you're going to set the others to zero. Okay, so simplify once. You are going to skip work term when you simplify, because the third part is draw free body diagram and write down what total work is. Okay, so that total work is like this work here. It doesn't necessarily have all the work done by the forces, because we need to think about, do we want to keep them as energy changes or the work on the right side, but you need to write them down first, and so your free body diagram should include all the external forces on the system. And the fourth one again is kind of put together everything, and then expand and simplify again. Okay, this is what we've been doing so far, and so what I want to show next is a little bit more detailed. So I'm gonna write the energy equation again. Let me go down a little bit more. Okay, let me use different color. So the energy equation, so this is the strategy that we follow. And first thing again, we write down what the energy conservation equation is. I'm going to start with the order. Delta UG, delta UE plus delta I plus delta IF equals to work done plus Q. Fix this. Okay. Okay, so first of all, again, there is a change in kinetic energy if there is a speed change. Okay, if the velocity or the speed of the object is changing, you're gonna keep delta K, because K is in the form of 1/2 mv squared. Okay, so you're thinking about that. This is how you introduce speed in the equation using kinetic energy. Okay, and delta UG is the gravitational potential energy, and it is defined by mgy. Y is always taken upward, and I usually take the bottom level of the motion as 0, so that Y will be always positive. You don't have to do it that way. I just don't like to deal with negative signs. But you have to always keep upward, straight up, as your y-axis. UE is the elastic potential, and it has the form of 1/2 kx squared. This little k is the spring constant. This capital K over here is the kinetic energy. They're not the same thing. Please be aware what they are. Check the concepts in the book if you are confused with those. K is the spring constant here, And if we have a spring-like object, we might have elastic potential energy if the spring is compressed or stretched, and there might be a change in that energy that might show up in the equation. Delta I is the internal energy. We don't really have an equation for I specifically. This is the general way of change in temperature or pressure in the system. Most of the time, delta I is going to be 0 for us. But we did split delta I into 2, and we said that there's also another form of internal energy that is due to the friction. And that friction is also known as like this, and instead of saying delta, like internal energy, you can say thermal energy, because that friction force, because of that friction between the surfaces, so there will be some temperature change between the surfaces. And so when there's temperature change, there's internal energy, molecular level energy changes, and that's why we have that delta IF term. And delta IF is, again, this is the delta. You're going to keep the delta. The other ones have like individual K, UG, and UE, and I need to find final minus initials. This one is not individual, and this is just as is. And this is found by the work done by the friction force, and it is negative of that, but it is also known as the definition of that. So it's kind of friction force times the displacement. Okay, this is how we know. But again, this is very important. This is not just IF, this is delta F. Okay, so that delta here is important here. And again, realize that, also be aware of that. There are no deltas here, so you have to find a final minus initials there, okay? So this is kind of what we do, and what I want to show is the work term here. So again, we look at the work term in kind of step 3. As we take a note, we need to have a free body diagram first. After we simplify, some of the things are 0, and then we look at the work term. But what I want to show, when you think about the work term, you might have the weight force doing work, you might have spring force doing work, you might have friction force doing work. Okay, you may want to choose the keep those terms as the work term on the right side, but you also have another choice, and that's what I want to show. Especially in chapter 8, that is what is emphasized. Chapter 7, it was more like finding the work done by individual forces, so keeping them on the right side and usually using kinetic energy and work relation, because the rest of the terms were taken to 0. But now you don't have to do that, and you can keep the energy terms instead. So I'm gonna keep delta UG if there's a change in elevation. That means Y is changing between 2 points, and that is related to the negative work done by the gravity. Okay, so if I put this on the right side as the work term, it would be positive work done by the gravity, because as it should be, right? So that's how it's defined. Since gravitational force is a conservative force, it can be associated to the potential energy, and this is the definition really. Delta UG is defined as negative work done by gravity. Okay, and the elastic potential energy change, there is one if there is a change in if there's a compress or stretch in the spring, and that is related to the work done by the spring force. So we use S here, spring force, that's related to the elastic potential energy. And again, there's a negative sign here, because if you put it on the right side, it becomes positive. Okay, and again, delta I doesn't really have anything associated with. Delta IF on the other side is related to the work done by the friction force. Okay, and it's negative of that. And this is the kinetic friction, because static friction object doesn't move, so there's no displacement. Think about the work definition, F dot D, so you need the displacement to have work. So static friction doesn't do work, so this is the kinetic friction. And so that's kind of how we're going to think about this work term, and this work term here is going to ignore, it ignores all these forces that I laid out, but keeps everything else. Okay, but these are ignored here, because you're saying that I'm going to keep those energy terms instead of the work terms. Okay, then ignore them on the right side. If there's another force, applied force or whatever that is, you're going to find the work done on the right side. But you're going to ignore the gravitational force, you're going to ignore the spring force and the friction force if you are keeping those three energy terms on the left side. Okay, that's really important. So that's briefly what we do, and most of the time, again, delta I and Q's are going to be 0 because there are no extra change in, like we're not, there's no heat transfer for Q to be 0, and also there's no other temperature and pressure changes. We're already keeping the thermal energy as the delta IF because that's due to the friction force. So again, there's, depending on the problem, you're gonna write more stuff out, but and also, for example, important things are, although you don't need to drive it because the equation is given, you gotta be careful with the equations, and if you want to keep those work terms on the right side, then know that the spring force is a variable force. The others two given in here are constant forces, so finding work will change depending on if it's the constant force or a variable force. But again, for these cases, you don't need to kind of drive the equations. They're already given in the equation sheet, so you just need to know what to use, how to use them. I hope this helps for this. Next, I'm going to talk about a little bit about momentum.